Hello, so I guess I am live and let me check if my voice is there. Hello, hello, hello. I guess now you can hear me. Live controller. Loud 6. Loud 6. Yes. Now, since I am audible, since our time won't sync anytime soon, so I am making this video because it was about how to use calculus. So only pen paper solution won't work. So yeah, a bullet is fired horizontally on a fixed block of length L. So length L is the length which it has penetrated. So let's say the bullet was so powerful that it penetrated this block. This won't be possible in real life because it would topple before penetrating it. So yeah, but let us say that it penetrated this L length where width is lesser than L. That is why it is not possible. So there is a bullet and it it penetrates it. If it penetrates the block and emerges from the back face with velocity v naught by eta greater than 1, resistance offered by the block against the penetration is proportional to the square of so this line is very important. Resistance offered by the block is against the penetration is proportional to the square of instantaneous velocity. So what does it mean is the backward force, the reaction force when the bullet is entering into this, the force is directly proportional to square of instantaneous velocity. So force, let's say F is equal to directly proportional to k up k into x square. Now, since F is mass into acceleration and acceleration can be written in two ways. Most of the Erodov question in which calculus is being demanded would be on acceleration only because acceleration has two ways to be written. Acceleration is equal to v dv by dx and acceleration is equal to dv by dt. Now, these two ways, and when we will use them interchangeably, that would give a relation, one of acceleration with distance and one of acceleration with time. So yeah, let us come back to this problem. K into x square. Now find the time of penetration. So we have to find out time. So let us first use dv by dt and see if it works. M into dv by dt is directly proportional to kx square. So here, since one term is x square and one term is dv, x square can be written as dv by x can be written as dv dot dt. So nah, this won't work because dt cube there won't be some strong integration that would become a strong integration problem. So we have to use another way. We will use v dv by dx. M into v dv by dx. Oh, it was square of instantaneous velocity. So yeah, I have written wrong here. It was square of instantaneous velocity. It was square of instantaneous velocity. So how to delete this? Yes, now f is directly proportional to k times v square. Now f is dv by dt is proportional. Due to this proportionality sign, we can replace proportional sign with is equal to, and it is equal to k into v square. Now v square will come here, m into dv by dt. Now I will send m this side and k by m into dt. K by m into dt is equal to 1 by v square into dv. 1 by v square into dv is equal to k by m into dts. So k by m into t, k by m into t is integration of this. So integration and integration, what will happen? Minus 1 by v, and the limits would be v naught by from v naught to v naught by eta. Now the problem is we don't know what is this k. So yeah, let us find out how. So velocity, we will put the limits like this. Let us keep it for the let us keep it let us keep it for the end, and let us now find how to find the value of k. So yeah, for finding the value of k, since I said that always they will ask question about acceleration, and acceleration can be written in two ways. So one time, since we have done dv by dt, now we will do m times v dv by dx is equal to k times v square. Now k times v square, 1 v will like this, 1 by v is equal to k by m dx. Okay, so length is given, that is why this would work. 1 by v into dv. Now integrating both the sides. Now 1 by v will become ln v, and ln v, when we will put limits to this, what will be the limits? V naught to v naught by eta, and at the same time k by m are constant. K by m dx will become x, and x limit would be 0 to l, since the length is l. Now this will become l, and this will become v naught by eta upon v naught, v naught by eta upon v naught. So ln, oh, 1 v naught by eta upon v naught, 1 by eta is equal to m times upon l. M ln 1 by eta is equal to what? This is some lengthy problem, so yeah, it is good for some J mains or advanced even, because how many minutes I have spent in this. Let us now focus on the question. M times ln 1 upon eta is equal to k by m x 0 to l. So L is equal to k. Now we have found the value of k. We can happily put this in this. Now let us put the value of k. M ln 1 upon eta whole upon l is equal to now sorry, k by m tha na, so k upon this m into l whole multiplied by t is equal to, we had to find the time of penetration, so take it to the other side at the end. So v naught by n, v naught by the way, this whole quantity will come out to be negative because penetration was opposing the flow. So v naught by eta minus v naught by eta plus v naught. Oh, let me think about this. Plus v naught minus v naught by eta plus v naught. Yes, this, sorry, this k part can't be it should be fundamentally negative, because uh, but ln wala part cannot be negative, mass cannot be negative, length cannot be negative, and time is obviously not negative, and this whole quantity is also positive. So somehow mass and length are balancing each other. I don't know why negative is not being here. So I will tell you when I will figure out. So yeah, this will give you the final answer. Take the ln upon 1 upon eta to the other side. So first question is done for us. In the second question, so background noise is basically your school is near my house, so they teach student dance. A motorboat of mass m is moving along a lake with velocity v naught. Motor boat v naught. Just at the moment t is equal to zero, the engine shuts down. Okay. Assuming the resistance to the water to okay, F is equal to minus k. F is equal to minus k. How long the boat moved? What we have been given is only that initial velocity v naught was zero and F is equal to minus kv. Okay. And at time t is equal to zero, no engine duty is there, so engine is not working. That means no forward force is there. Now F is equal to minus kv, so let m. And last question, bullet's mass was not given. So yeah, finally it got cancelled out. Okay. So here, since mass of boat is given, m into acceleration is equal to minus k into v. Now, firstly, we have to find out the how long the motorboat moved with the shutdown engine. So, firstly, I will write dv by dt. Now, why I write dv by dt first? Like in last question, also I had written dv by dt first, and here also because I am certain that I will have to use dt wala equation because the question is demanding me to find out time. But I don't know if I have to certainly use dx wala equation or not. Maybe I can find out the answer from here only. So since k is given, now minus m by k d oh. Huh. So 1 by v dv is equal to minus k by m dt. So 1 by v will give you ln v. How long the boat will move with the engine shut down. So firstly, if we will do the conceptual breakdown of this question, there were two possibilities that initially the boat was going upstream and finally the and initially the boat was going upstream and initially the boat was going downstream. But I would say the upstream statement would be correct because at the end of the day, when the engine is turned off, the resistive force is directly proportional to minus k into velocity. So resistance is being offered in the opposite direction of the current velocity. So yeah, it is opposite. So it was upstream. So why I said this was because I wanted to put limits. Finally, uh, how long the boat moved, that means finally when its velocity became zero, because after the point of time when the velocity will become zero, the boat will still move but in the opposite direction. So velocity I will put from final velocity is zero and initial velocity is v naught. Ln zero. Okay, and that would one second. Okay, so yeah, that would equate with minus k by m into t. This will certainly be negative. Ln 0 minus ln 0 is defined or not? Like e ki power what is equal to 0. E ki power what is equal to 0 is not defined only. Let me think about it where it is wrong. dv by dt minus kv f is equal to minus kv mass into acceleration. Mass into dv by dt. Yes. mass into deceleration basically is equal to minus k times velocity. Velocities of the object, so yeah, we can equate it. Minus k by m, 1 by v into dv, and minus k by m into dt. That is minus k by m into t, and ln 0 1. So ln 0 will be undefined. So somehow the answer is turning out to be infinity because the boat was going up, not upstream but downstream. So there is a problem. There is a problem. Okay, so I, if in a scenario I had to put the velocity is changing from zero to v naught, let's say, let's say, then also then it would be ln infinity. Ln infinity is still not defined. So yeah, I'm going somewhere wrong here. So let us start the question from the beginning. Sorry for wasting so much of time. But yeah, we are learning something. A motorboat of mass and moves along a lake with velocity v naught at time t is equal to 0. The engine of boat is shut down. Okay, so engine of boat is shut down. So yeah, at time t is equal to 0. Yeah, so it is quite evident that yes, this scenario can be possible. So there is nothing wrong in this question. Assuming the resistance of the water to be proportional to the velocity, F is equal to minus kV. Okay, F is equal to minus K times V. F is equal to, now I have to make the final velocity is equal to 0, right? F into dv by dt is acceleration only, is equal to minus K times V. Again, I have m times dv by dt is equal to minus K times V. Okay, minus K upon m is equal to whole times multiplied by dt is equal to 1 upon v into dv. तो इसका इंटीग्रेशन तो ln v ही आता है. ln v, and there is some problem in the limits. Limits can't be put 0. ln 0. ln 0 is, there is no meaning of ln 0. So ln tends to 0 or something. So this question will be on me. Let me, I will find out the solution and then send you. If this was question from YouTube, I would have solved it, but now I don't remember. It may be before question number 23 because before question number 23 I solved in the initial part when I was in 10th. So yeah, maybe. The velocity of motorboat as function of distance. ये तो हो जाएगा. The velocity of motorboat as the function of distance. F is equal to minus kv is given. F is equal to F is m into v dv by dx is equal to minus k into v. So yeah, v to v subtracted, kx is equal to mv half. The velocity as a function of distance covered with the shutdown engine. With the shutdown engine, exactly. As well as the total distance till it stops. Total distance. Okay, if we will solve the B wala part, then we can move to A wala part again and we can solve it through some other way. But I don't know what was the problem in my first way. So, yeah, let us continue. So, in this second question, it is asking us to relate x with velocity, and it has given us only one relation, m into acceleration is equal to minus k into v. So it is pretty evident that we have to use the formula a is equal to v dv by dx. So now mass into velocity dv by dx is equal to minus k times v. So k is this. Now m into v is equal to minus kx. So momentum is equal to minus kx. Momentum is equal to minus kx. It is it true to say? So yeah, net force can be, yeah, derivative of this function will give us the net force. So yeah, okay. So mv is equal to minus kx is the final answer. I didn't put limits this time, so there is a problem. So it started from the velocity v naught and it ended with velocity 0. So minus mv will be here, and x is the distance traveled, so 0 to x and minus k. So mv is equal to plus kx आ जाएगा. So mv is equal to plus kx. Now mv is equal mv is equal to plus kx नहीं आएगा. हाँ, mv is equal to plus kx ही आएगा. ठीक है, ठीक है. And when we will put the velocity is equal to v naught, we will get the distance. Now when we will put the limits of this from 0 to from v naught to 0, we will get the value of the change in x, so delta x. So I should write this in another way because uh, I don't know. I am like, yeah. So I should write it in this way: m into delta v is equal to minus k into delta x. This is better statement because when I had written x in v, it would somehow imply that it is talking about the instantaneous velocity and all of that, but no, it is about the change in velocity. So distance covered, yes, delta x is distance covered, and the velocity of the motorboat. So velocity, final velocity of the motorboat will be v. So it is asking about the instantaneous velocity of the motorboat. So m into v minus v naught is equal to minus k into delta x. So yeah, this is the final answer to the b part. Now when it will stop, the delta x will come out to be, this thing will become v naught, sorry, m v naught upon k will be the final, like final velocity is 0, negative negative will cancel out, yeah, m v naught upon k will be the delta x. Now if we have to find out the time, so acceleration is not constant. So now what we have to do is relate distance with time. So dx by dt. Let me just, now I have to relate it with time, is equal to velocity, and velocity as function of x, we know. No, velocity, I don't know the function as it as function of x, we know it as function of delta x. So does that matter? No, that does not matter. So another attempt, this can be wrong because I'm not very much clear in my mind. Another attempt to this question will be m into v minus v naught is equal to minus k times. So delta x initially, if I will take the x as 0, then it will come out to be x only. Yeah. So we can write it as mv minus mv naught is equal to minus k x. So v, I can write it as m into dx by dt is equal to m v naught minus kx. So x will, Oh, x wala term will get divided in two places. So what? So what? So what? Constant ka integration will constant ka integration will give you the same constant, right? Mm, 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 mm. Da-na-na-na-na. M dx by dt plus kx is equal to mv naught. M dx plus kx dt is equal to mv naught into t. Now, since x is also changing, x is the fundamental quantity here, so this should not have any problem in the. I don't know if this answer will come out to be as correct or not, but just let me know. M dx. So if I will integrate, it will become m into x along with limits kx t is equal to mv naught into t dt, and I integrated it. Now mx upon mv naught minus kx is equal to total time taken. If this is correct, then let me know. Otherwise, not. Next question: the mean velocity of motor boat over the time interval beginning with the moment t is equal to 0, during which the velocity decreased to 1 upon eta times. The mean velocity of the motor boat. So we have to find out the delta x first, and then the time. So time wala part is, so since I'm okay, let's solve this. Let's solve this. जिगरा दिखाता है इस सवाल के लिए. The mean velocity of motor boat over the, so delta x will be delta x from here mv naught upon k. No, no, sorry, m into delta v upon k minus k, m into v naught upon eta minus v naught upon minus k. ठीक है. Delta x was easy to find, and delta t. So delta t will be mx into mv naught minus kx. So that is as function of x. So I have to find out the t as function of velocity. Dv by dt 1 upon v. So yeah, as function of velocity, if I will have to find out that, it will be difficult. So yeah, the C question, because we were not able to solve A part, the C question was also not solved. The C part was also not solved. I'm sorry, but yeah. Let us move to next question. Number of compounds HF, H2, 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 H2. Okay, which of one of the following compounds has maximum dipole moment? Okay, CH4 का तो zero हो जाएगा directly. Like CH4 is sp3, so CH, like it is completely symmetrical compound. So any effect of anyone will just get cancelled out by other counterpart. NF3 is a candidate. NH3 is a NF3 and NH3. NF3 and NH3 were exception kind of. I don't remember it completely. And PF5. PF5 is PF triangular bipyramidal. Right. F F. So this will also give zero dipole moment. And in NF3 and NH3, if we will think about it, we will, since while thinking, it seems to us that NF3 has more dipole moment. That is why NH3 has more dipole moment. Because in NH3, uh, NH3 में there was something exception kind of. let me just try to recall what was the exception. Nitrogen, lone pair, F, 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 5 इलेक्ट्रॉन्स होता है, so yeah. And N, H, H, H. So since they are more electronegative, these are more bulky elements. It was exception dipole moment only, right? Yeah. Since F is more bulky, it will push the other elements to the other side. That will try to make this नीचे वाला triangle more of planar. But in NH3, since all these, I don't know if this logic is correct also. Yeah. But in NH3, all these hydrogens are same. So the arrangement in space like this is also possible. That is why this will show more dipole moment. So NH3 will be the correct answer. There was some kind of exceptions, or I guess this was the exception only, but yeah, there was some exception. So yeah, that was all for today. Let me. Oh, it was half an hour video. That sounds too long. Thank you, thank you.